Hey guys, welcome back. Today we're going to talk about lesson 5.3, and we're still solving systems, and this time we're going to use a method called elimination. So what we want to do here is we're going to look first at a first objective, and elimination is an algebraic way of solving systems. And so once again we're solving systems, so we're looking for an ordered pair that satisfies both equations, okay? And the first objective here is that we're able to align the terms of an equation in the system. So you have to align terms so that the x's are with x's and y's are with y's. And then we add the equations to eliminate a variable. Okay, so for objective 1, we're just going to be adding equations, and it eliminates a variable, and we'll get more into that. And then after we eliminate one of the variables, then we solve for the remaining variable, and we use substitution to find the ordered pair that we're talking about. Okay, elimination is a method of solving systems in which we use addition, subtraction, and multiplication to eliminate one variable, and this allows us to solve for the remaining variable. Okay. So our first example here, and this is the same example that you'll see on your success packet, is 3x minus 4y equals 10 and x plus 4y equals negative 2. And it says align like terms, but as you can see, when we mean align like terms, we want the x terms and the y. You would just, you want the x terms to be on top of each other and the y terms to be on top of each other, okay, and the constant terms to be on top of each other. And so this is what I mean. I have x terms on top of each other here and y terms on top of each other here, and then the constants on top of each other. So then we look at the coefficients of x and the coefficients of y, and we determine, do any one of these variables, do they have opposite coefficients? In other words, negative 3 and 3, negative 2 and 2, negative 1 and positive 1, those are opposite. Are the coefficients the same, or are they not opposite or the same, and all coefficients are different? The reason we do that is because that's going to tell us whether we add, subtract, or do we multiply first, okay? So in this case, because our objective here is to add, we'll notice that the y coordinates here, the y variables, they have opposite coefficients, okay? They have opposite coefficients. The coefficient of y in the first equation is negative 4, and the coefficient of y in the second equation is positive 4. So they have opposite coefficients, okay? So the next step here is then to add the equations. So we rewrite the equations just like they are on top of each other. And the reason we're adding here, okay, the reason we're adding is because one of the variables has opposite coefficients. And when I add opposites, they cancel each other, okay? So this 3x plus x, just like I would normally do, is 4x. And negative 4y plus 4y, they cancel. Okay, and that becomes 0, and then this equals 8 because positive 10 plus negative 2 equals 8. Now, the next step, okay, we've added the equation, so we have 4x equals 8, and the next step is to solve for this variable. Okay, so 4x equals 8. That's what we got in the last step when we added, and now I want to solve for the x, okay? So I'm going to solve for the x, and I'm going to get x equals 2. Now, all of this is in your success packet, and you should be following along, filling that packet in, okay? Now, I have the x coordinate, because remember, I'm looking for an ordered pair. So I'm going to go back into one of the originals, and it doesn't matter which one, and you're going to substitute the 2 for the x. And I'm going to go back to equation 2 in the original, which was x plus 4y equals negative 2. And I'm going to substitute this 2 for x. So this 2 goes in place of this x, see that? Plus 4y, sorry about the lights, 8, okay, plus 4y equals negative 2. And then Now I'm just solving this equation. I'm going to subtract 2 from both sides. Okay? And let me move this down a little bit. I get 4y equals negative 4, divide by the 4, and y equals negative 1. So is there another step here? The last step is to write the solution, and it says here, write the solution as an ordered pair. Here's the x coordinate. Oh, I messed that up, didn't I? Should be the y. That should say y, not x. And here's the y coordinate. So 2, negative 1 is the solution to this system. 2, negative 1. Let me fix that too. Sloppy right. Okay? So 2, negative 1 is the solution to this system. So that's example 1, and using addition, so that'll take care of objective 1.